continue on making the volume calculations. So last time we introduced a couple of things, especially the fractional unit cubes. We spent a lot of time at the end of the last lesson talking about it. A lot of today's is going to be talking about packing a prism with fractional cubes. I'm going to be honest, if you're from A2 and listening to this, it's a whole different lesson because we're not spending nearly as much time on the fractional cubes as I did last class. I just want you guys to be able to use the volume formula, okay? So our worked example, we are going to introduce this to you so you understand the concept. I'll be honest with you guys, these are the types of questions they love to put on tests because this actually tests a whole bunch of different concepts all at one time. Yes, sir? If you had listened, I'd already said you're getting your test back at the end of class. I know, that's the hard part, Maverick. You have to listen. Okay, consider our prism. I have a prism that's 1.5 by 2 inch by 3 inch in our 3 dimensions. If I'm going to use 1/2 inch cubes to pack it, how many 1/2 inch cubes would it take to get across a distance of 1.5? 3, right? How many cubes would it take to get across a width of 2 inches? 4 of them. Meaning, on my base, I now have 3 cubes by 4 cubes. So how many total cubes are on the base? It's 3 cubes by 4 cubes. 12 of them. Somebody see that? So my base takes 12 1/2 inch cubes. I also have a height of 3 inches. So how many cubes is it going to take to go all the way to the top? They're 1/2 inch cubes. 6 of them. So I have 21 cubes in the base, but I have to have 6 layers of them to get all the way to the top. Everybody okay with it so far? That means for a total of 72 cubes to fill our prism. Make sense? Okay? Now, to actually calculate the volume, all we're going to do is take the number of cubes that we used and multiply it by the volume of each one of those cubes. So remember we said we started with a 1/2 inch cube, right? So to find the volume of that 1/2 inch cube, all we're doing is multiplying it because cubes have the same dimensions in each direction. So 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So each of those cubes has a volume of 1/8 cubic inch. Is everybody tracking so far? Who said no? Leanne? Which part didn't you understand? Okay, so we're using 1/2 inch cubes. You understand that? And we showed you yesterday how it took 8 of them to make the space of 1 unit cube. Do you remember that example or last class? So that means that each one of those individual cubes has a 1/8 cubic inch volume. They take up 1/8 of an inch of cubic space. Okay? How? Because when we did the 1/2 inch cubes, we'll just go back to that example real quick to make sure everybody's tracking. I said instead of a whole unit cube, I have a 1/2 inch. So it takes 2 to get that distance, right? So that's my length, but it also takes 2 to get the width, correct? But then going up, it also takes 2 to get the height, correct? So then I had to fill in the rest of it to make up for that whole unit cube. So when I do that in all 3 dimensions, I end up with a cube that looked like this. We have 2 cubes in each direction to make up the full unit cube. So it took 2 going this way, 2 going this way, 2 going this way. I fill in all of the sides. How many cubes did I end up having, Melinda? 8 of them. So that means that each individual one has a volume of 1/8 because it takes 8 of them to get to 1. This is making sense so far. Okay? So now that we have 72 of these cubes that each have a volume of 1/8 cubic inch, to figure out the total volume inside of my right rectangular prism, all I'm going to do is multiply the 72 times the 1/8. So I take 72 times 1/8. 8 will go into 72. 9 times 8 goes into 8 once. 9 times 1 is 9. 1 times 1 is 1. 9 over 1 is 9. So how many cubic inches is it? 9 cubic inches inside of my right rectangular prism. Does this make sense? Everybody good so far? Okay. Step 5. Now we can use the volume formula to check our answer, just as we did with area. First step is write our formula in basic form, length times width times height. I then go to my picture. Mihana, what's my length? 1.5, 3, or 2? 3 is my length? Interesting. Okay.
No. It doesn't matter.
Guys. Shh. So we're saying 3 is the length, thanks to Mihana. Leanne, what's my width then? 2. So we're saying 2 is the width, meaning 1.5 is the height. Does everybody agree with those 3 measurements?
No.
No.
Matter, but still, yeah, it doesn't matter.
Good. Why doesn't it matter, Sophia?
Because they're yeah, the commutative property.
Of
The numbers.
commutative property of multiplication.
You should do it because it looks nice and
Okay.
it makes sense.
So I would actually agree with all of you that were groaning when Mihana gave 3 as the length. For me, I would have said the length is here, the width was there, and this is the height. But because I'm multiplying, it doesn't matter. Once I have labeled it on my picture, then it becomes very easy. I literally just write them down. Anytime I have a mixed number, what's my first step? Get? Awesome. Slam dunk. Turn it into an improper fraction. Now I'm just multiplying the numbers. I have one reduction. Those 2's go away. 3 times 3 is 9. 1 times 1 is 1. 9 over 1 becomes 9. And you can see that from the formula, it is 9 cubic inches. Liam, you need to change out your chair. You're not allowed to use wobble stools anymore. Change it out. There's a regular one over here you can use. Yes, Liam. Not you, Liam, not Liam. You're okay on that one. So, you can see, using the volume formula, I was able to get the same answer as by using fractional unit cubes. You see it, Maverick? You see it? It's the same number, right? 9 cubic inches. Let me add a note after grading your guys' tests. Did I not stress enough how important it is to put the proper units on?
No. You did. You would yell at us if you didn't.
You said you would yell.
Every time I have ever done one, I have pointed to the units and said, guys, make sure you include this or you're losing points. So apparently Destiny just hasn't been paying attention. But for the rest of you that were, there's a lot of points lost on the test because you didn't put the right units in. When we are doing area, it is always going to be units squared. When we are doing volume, it will always be units cubed. You have to have it. Okay? So those are the steps. Doesn't matter which size fractional cube you use to pack the right rectangular prism in the worked example. Did I have to use half unit cubes? Could I have used something else as a fraction? No, so it had to be half unit cubes?
I never get yes, but you can always get the same answer using different size cubes.
I can?
I think so. Maybe. I don't.
Yes, No, maybe so.
I mean, with different numbers.
Which one?
If
No,
you use
maybe
like a
so.
full cube.
That's 3 options.
Maybe.
Which one is
No.
correct? No, I can't. I can only use 1/2 cubes.
Mr. Man, no.
Say yes.
No, you can't
Yes.
actually.
I'm just going
Yes.
to tell
Yeah,
us
mine
this.
Yeah.
You can use different cubes.
Can I use any different cube?
Why are you making this so
No.
difficult than it has
Oh,
to
you
be?
can use like.
I'm just asking the question they asked. What do you mean making it difficult?
Like cube, like two something.
Okay, let me give you a hint. Could I have used 1/4 unit cubes? Could I have used 1/3 unit cubes? How did I get 1/3 to go into 1/2?
I don't know.
You do math.
Yeah,
Math says 1/3 won't go to 1/2.
Oh, math is no.
No.
You can use like.
Hold on, Liam.
Big brain. What you like?
But would a 1/3 unit cube work for that? On the 1/2. But it has to work for all 3 dimensions. So I couldn't use a 1/3. Could I use a 1/4 unit cube? Yes, because 1/4 will go into 1/2. Because basically it's 2 1/4 to make a 1/2, right? 2/4 is 1/2, same thing. So the answer to your question is, does it matter which size? Yes. They need to have a common multiple. As long as I have a common multiple, then I could use any size of cube. The key is a common multiple, especially of the fraction piece, to make sure it will go in evenly. Hello. If all of my numbers are whole numbers, then I could use whatever size I wanted to, because they're all going to go into ones. But if I have a mixed number in there, Hannah, you might have to move today. You're not doing well. You're doing way more than that. And you need to stop. Okay, let's go to page 93. Now, if I'm looking at this rectangular prism, this one is different. Consider using fractional cubes to determine its volume. How do I determine which size cube to use? What size cubes do you think we should use on this? Thirds? Is a third going to go into a half?
Yeah. Maybe like 3, 6. That could turn into.
3/6 is not thirds.
Oh. Wait.
Jaden?
6.
1/6? How did you figure that out?
And?
Because 3 times 2 is 6, and 2 times 3 is 6.
Common multiples. So here's what we need to do. If I look at the fractional pieces of my right rectangular pyramid or prism, and I find the LCM of those, so in other words, I use 2 and 3, find my LCM, one's going to go into both, meaning they are relatively prime. So my LCM is just multiplying the 2. Gives me an LCM of 6. And I just use the fractional cube of 1/6. That will go into both. Now the key is, it needs to be a multiple of that. I could use a 1/6, I could use a 1/18, 1/24. They have to go into both of them though. Okay? Now you want to use the smallest one, because as I'm going to show you maybe in one example, what I did like 5 of them last class. It was a nightmare.
Oh, God.
Wait till you see it. It's bad. Okay? So 1/6 would be able to fit in all those dimensions. Make sense? Okay. Now we're going to use a worked example on this one. So step 1, decide which fractional cube to use. Identify the LCM of the denominators to determine the dimensions for each. So Jaden picked it up right away. Well done. So the LCM of 2 and 3 gave us 6, meaning I'll use a 1/6. Now here's where this gets really messy. So the volume of each of those cubes is 1/216. Because to find the volume, I do length times width times height. In a cube, they're all the same. 1/6 times 1/6 gives us 1/36. 136 times 6 gives us 1/216. No, it's not fun. The numbers get up really quickly. Anytime you're doing exponents, even if it's just an exponent of 3, the numbers get big. Now, step 2, determine the number of fractional cubes needed. So all you're doing is you're taking each of the dimensions, in this case the 3 for the length, and then you're dividing it by the 1/6. Remember, we don't really divide fractions. What do? Multiply by the reciprocal. Meaning I keep the first number, I change it to multiplication, I flip the second number, that's where we get the 18 from. Okay? Second one, 1/2, I keep the first number, change it to multiplication, flip the second number. I have one reduction, those both can be divided by 2, gives us 3. My third one, I have an improper mixed number, so what's the first thing I have to do? Slam dunk, I need to turn it to a mixed number, gives us 4/3, change it to multiplication, flip the second number, one reduction, gives us 8/1 or 8. So that's where those 3 numbers came from. So I need 18 cubes for the length, I need 3 cubes for the width, and I would need 8 cubes for the height. Does that make sense so far? Everybody tracking? I haven't lost anyone yet, right? So now to figure out the total number of cubes, of these fractional cubes that I need, I'm just going to multiply those numbers. So 18 times 3 times 8 means I need 432 of the cubes. To find your total volume of the right rectangular prism, I take the number of cubes that I did, I multiply by the volume of each of the cubes, and then I simplify. So that would be 432 over 216, or 2. Meaning, the volume of the right rectangular prism is 2 cubic inches. Now here's the key. How many of you have I lost at this point? Thank you for being honest. So which part did I lose you at? Do you understand how to find the LCM of the 2 numbers? That's where I started.
When you stopped doing the reciprocal thing and started doing something different. When you started
Okay, well, let's just talk to you because I lost Melinda before that, apparently. So, do you understand? I had 2 fractions in the numbers that I was using. 1 1/3 and 1/2. So there were 2 fractional pieces. So I needed to find the LCM of the denominators, the 2 and the 3. So they gave me the denominators. Those are the numbers I needed to find the LCM for. Good so far? So I found the LCM of 2 and 3. You good with that? Which was 6. So that means that the fractional cube I need is 1/6.
Where would you put the 1/6 down?
The 1/6 is the cube that I'm going to use to go across there.
Oh, it's 65.
Yeah. So instead of using our earlier example, this is going to get messy, but instead of 1/2, now I'm using 1/6. So it's going to take 6 cubes across to equal 1. And 6 wide and 6 high. That's why there's 216 of them.
So basically it times 2 by 3 basically to get 6.
In this case, yes.
Then you would times it by 3 because that.
No. Then, so that means my cubes are going to be 1/6 each. Okay? But I have it 3 inches across. So I'm dividing the 3 inches by 1/6 inches to see how many of those cubes it takes to get me across that length.
1/6 times 1/6 times.
That's the volume of 1 cube. So if I have a 1/6 inch cube, because I said I needed it to be 1/6 to divide it up, means that each one of those cubes has a volume of 1/216 cubic inch. In other words, if I did like the 8, I'd have to do 216 to equal 1 cube. Okay? So that's where that piece came in. This piece here, Callie, where I lost you, this part here is just saying, okay, if I'm using 1/6 unit cubes, how many do I need to get across the entire 3 inches? Okay? Because there's 3 cubes in each inch, right? Because they're 1/6. But there's 3 inches, meaning if I were to draw the picture like we did the other day, in the 3 inches, so that would be roughly 3 inches like that. Each of those is divided into 6. So it's going to take 18 cubes to get all the way across. Does that make sense? Okay? Now because they're 1/6, it's going to take 3 of them to get all the way to the back. That's where the 1/2 came in, is 3. Then with the 1 1/3, it's going to take 8 of them. So you're good on that. So now to figure out how many cubes we used in the entire thing, it was the 18 by 3 by 8 for 432. Okay? Now to find the total volume of my figure, I have 432 of those little cubes that I broke it into. So I took 432 of these to fill up the container. Each one of those has a volume of 1/216. When I multiply the 432 cubes by their volume of 126, I get, or 1/216, I get 2. Meaning the whole figure had a volume of 2 cubic inches. Make sense? Okay. Now, we are going to do the last class we did 4 problems like that. This class we're probably going to do 1. So, how was the number of fractional cubes needed to pack the prism in each dimension determined? What did we do? Good. So we found the LCM of the denominators. And then we did what?
Determine the number of
How?
by multiplying or 3 times 1/6, and then
Multiplying?
or well, yeah, because you change it.
But we didn't. We 3 and 1/6. We did what? Divided. Okay. Then you divided each dimension by the unit cube. Actually, let's use the fractional unit cube. Don't worry, I'll move in a minute. You also have 2 boards, don't forget. Okay? So I took what I found and I divided by the unit fractional cube to figure out how many cubes it took. But our first step was finding the LCM of the denominators. Make sense? Okay. Now they just asked about how I found the number. To find the actual volume, then I multiplied the number of functional cubes by the volume of each individual one, which is where that one gets really messy. Okay, let's go to the next page, 94. Okay, it's on the recording. You also have neighbors. Some of your neighbors may have gotten it. Instead of 1 6-inch cubes, suppose I use 1/12. How does this change the volume of the rectangular prism? First off, could I have used 1/12 unit cubes?
Yes.
Yes, because that will go into 1/2. It'll also go into 1/3, right? How does that change the volume of the prism that they're in? Sophia? The volume of the cube would get bigger or smaller based on the size of the fractional ones?
No, but when you're finding, like in step 2, when you're finding the numbers, wouldn't those get bigger?
Those would get bigger. I'd have more 1/12 unit cubes, but does it change the volume of the rectangular prism? Austin, please stop.
So it wouldn't, because it's 2 fifths.
What do you think, William? Yeah. Put your chair down. I've already had one person fall today. How's it going to change the volume of the rectangular prism to use 1/12 instead of 1/6? Right, so there'll be more cubes inside there, but how does that affect the volume of the right rectangular prism they're in? Jet?
It doesn't affect the volume, or it doesn't affect the shape. It's just different numbers, but it's the same volume.
Good. That's the answer we're looking for, guys. It doesn't matter if I use 1/6 or 1/12. The volume inside will be the same. I'm just going to have more of the cubes. Okay? It won't affect the volume. So we won't see any change on the volume. What is another way to determine the volume of the prism without packing without cubes? Callie?
You multiply the numbers it gives you.
Which numbers do I need for volume?
The
Height,
length and width.
I could use the volume formula. V equals LWH. Yes, Austin? Nah. The issue there is finding the volume of the rectangular prisms, then you still have to use the unit cubes. Okay, so as you can see, we have two models to use. Use the method from the worked example to determine the volume of each, then use the volume formula to check your answer. This is where I struggled last class. Okay? We're going to go through one more example together because I'll be honest with you, especially for those of my higher achieving students, these are the questions they'd love to throw on the major tests because this tests about 5 different mathematical concepts. Okay? Then we're gonna spend the rest of the class doing the volume formula, which is really what you need to be able to do to find volume. But we'll do at least one to help you understand the process of how you can do it using fractional cubes. So let's go back to our step 1. We need to find the LCM of the
Figure.
no
No, I messed up.
denominators. So I look at my fractions. I have a denominator of 4 and 8. So I need to find the LCM for 4 and 8. Divide both those by 2 gives me 2 and 4. Divide by 2 again gives me 1 and 2. 2 times 2 is 4, times 1 is 4, times 2 is 8. So I have an LCM of 8, meaning I'm going to use 1/8 unit cubes. Does everybody understand how and why we did that?
No, I didn't.
Do you not understand how or the why? Who was it that said no? Jaden? Okay. Do you understand that the two fractions they gave us had a denominator of 4 and 8?
Yeah.
Do you understand how to find the LCM of 4 and 8?
Yeah.
Do you understand how to put a 1 over that? Okay, that's how we figure out what unit cubes to use. Okay? Next step is figure out how many of the cubes we need in order to go across each side. So, let's try this again, Mahana. Mahana, what's my length? You have gum again. And width? 3/8. Yes, you have gum as well. You can do height. Does everybody agree with those? Those are good. Would it really mattered? No. So now, next step, I need to figure out how many cubes will go in each direction. So we'll start with our length. So our length, we had 3/4. I'm dividing it into 1/8 cubes. Does everybody understand that piece? Because we've determined we need 1/8 cubes. So now I need to figure out how many it would take to cover that area. So 3/4 times 8/1. One really good thing about this, we'll always have reductions because I know that this is an LCM. I can divide both those by 4, means that I need 6 cubes for that length. For my width is 3/8 divided by 1/8. Keep, change it to multiplication, flip. Those I can both divide by 8 means I need 3 cubes for the width. For my height, we had 2 inches divided by the 1/8. Keep the first one, change and flip. Both ones on the bottom just means I need 16 cubes. Yes, Liam? Because someone was doing things they shouldn't have. Now, to figure out how many cubes I would need to fill the entire prism, my base, I would have 6 wide by 3 across. So how many cubes are in the base? 6 by 3. 18. So all I'm doing, guys, 6 times 3 times 16 gives us 18. And it's a height of 16. So I just need to do that math. 18 times 16, 48 gives us 108. 081. So we have 288 cubes inside of our right rectangular prism. Brandon, you writing this stuff down? You look kind of distracted today. Now, here's the last step, and here's where this gets really messy. Here's why I don't like this method. Because in order to find the volume of a 1/8 unit cube, I have to do 1/8 times 1/8 times 1/8. 8 times 8 gives me 64. 64 times 8 gives us 32. 48, 512. So we're doing cubic inches. So each of those 288 cubes has a volume of 1/512 cubic inches. So I now, in my next step, would have to say 288 of the cubes times 1/512 gives us 288 over 512. Is that in simplest form? No. They're both even numbers. So I'm just going to rewrite this over here because this is about how much room it's going to take. 218 divided by 512. I can divide them both by 2. Gives me 109 over 256. Oh, I wrote the number wrong. It's like something's not right. It's 288. 144 over 256. Dividing that one by 2 gets us 72 over 128. Dividing those by 2 gets me 36 over 64. Dividing those by 2 gets me 18 over 32. Dividing those by 2 gets me 9/16. You see why I did a whole new row for it?
You should Mr. Mark, this won't fit.
It will fit.
No, I ain't got no room.
So what is my total area for this, total volume, sorry, for this right rectangular prism? 9/16 cubic inches. How did I find it? By packing it with cubic unit cubes of 1/8 inch. So what is our second option? Using the volume formula. Volume equals length times width times height. We've already identified all three, right? So my volume is 3/4 times 3/8 times 2. 2 goes over 1 because I need to have all improper fractions. I have one reduction I can do. I have a 2 on top becomes a 1. 4 on the bottom becomes a 2. 3 times 3 is 9. 9 times 1 is 9. 2 times 8 is 16. 16 times 1 is 16. Please don't forget your units. So I can do this, or I can do this. You guys like using the fractional unit cubes?
Mr. Martin, you're telling us we went through all that trouble, all that clobber, when there was just a simple way to do this, which was just multiplication difference.
Well, if it makes you feel any better for A2, we did this 3 more times.
Why?
Because this is a brand new curriculum. It's the first time I taught it, and I do try to be very good about teaching the curriculum. Have I now taught you guys what they want you to do? Hold on. Guys, have I taught you what they expect you to do?
Yes.
Okay? Have I shown you how to do it?
Yes.
Okay, last class I made them do a whole nother one. Actually, I made them do 2 more using the fractional and this. We're not doing fractional anymore, guys. Just find the volume. Okay, so part B, find the volume. You can use either method you like. I will give you guys 2 minutes. Go. So let's try this again. I forget who I started with. Sophia, what's the length?
The length is 3.
Okay. What is my width? Austin?
1/3.
1/3. Meaning my height is 1 3/4.
What?
He was just trying to throw you off. Does it really matter? No. I agree with all of you. I would have put 1 3/4 as the width. Again, how many times have you guys ever seen me do any of these formulas without writing the base formula? Never. No. How many times have you ever seen me do it without labeling the length, width, and height, or base and height, or length and width in the figure? No. Because if you'll do those 2 things, the last step should be super easy. All I'm doing is substituting these numbers in. So I have the length of 3 inches, the width of 1/3 inch, and the height of 1 3/4 inches. And all I'm doing is multiplying them. So to do the actual multiplication, as soon as I see a mixed number, I know I need to immediately do what? Slam dunk. I need to make this into an improper fraction. Okay? So I'm going to rewrite the rest of them as improper fractions as well, just using the numbers. 3 times 1/3 times 7/4. I have one reduction. I've got a 3 on top and bottom. Those go away. Now it's just 1 times 7 is 7. 1 times 4 is 4. 4 goes into 7 once with 3 left over. Do not forget your units, guys. And the answer should be that easy. Questions? Austin? Should have been the exact same way, unless you did the fractional units. Okay, let's go to page 95. We've got 2 problems on this page, although part 2's got 3 parts. So we'll give you up until lunch to get going on those. Okay, let's look at these. I didn't tell you you had to use the fractional cubes. Please don't. Just use the formula. It's going to be way easier for you. So start with your base formula. Length, width, height. On your paper, you should label length, width, height. If you have done so, it should be very easy. All I'm doing is 1 1/6 times 1/2 times 2/3. Mixed number means I have to slam dunk. Gives us 7/6 times 1/2 times 2/3. I have one reduction. I've got 2's on each. That's all what I've got. 7 times 1 is 7. 6 times 3 is 18. It's always cubic inches. Okay? Part 2. 7/18.
How?
I got 7 numbers.
6 times 3 is 18.
No, I know why. Because you
Can't divide
said
7 by 2.
you said that we can divide 6, 2, and 2 together.
And then 6 will equal 3.
But you can only, I said you can only do one top and one bottom. I said, but then if you have another one, you could do another one, but you don't have another one.
And you just said you couldn't do it.
If you have more than one.
It was miscommunication.
You understand why?
On your part.
Guys, Arlene packs a moving truck with cube-shaped boxes that have side lengths of 1.5 feet. The back of the truck is a rectangular prism with the dimensions 7.5 by 15 by 7.5. What is the volume of each box? So that's the box themselves, meaning 1.5 times 1.5 times 1.5 gives us 3/2 times 3/2 times 3/2, or 27/8, or yes, 3 3/8 cubic feet. Okay? Thank you. I'm sure you will. Now, determine the number of boxes that will completely fill the back of the truck. So you have a couple of different options on this. You have 2 different options that I can think of offhand. I can say it's 1.5 feet for each, and I can go by each dimension to figure out how many it would be, which honestly is probably the easiest way to do it. So if I have 1.5, 7.5 divided by 1.5, that's going to give me 14 15/2 times 2/3, or 5 boxes in that direction. I have 15 divided by 1 1/2, which is going to give us 15 times 2/3, or 10. And then the third one is 7.5 as well. So that's another 5. The hard part on that is you got to visualize what's happening. I can get 5 boxes this way, 10 boxes this way, and 5 boxes high. How many boxes is that? 5 by 10 means how many boxes across the bottom? 50. 5 stacks of those gives me 250. So you can pack 250 boxes. Okay? Now that would be very tightly packed. There is no room for air in there, but given those containers, you should be able to do that. Calculate the volume of the back of the moving truck. There's the numbers that they gave us. Whoa. I didn't break anything. So, volume is the length, width, height. So, 7.5 feet times 15 feet times 7.5 feet. That gives us 15/2 times 15/1 times 15/2. Unfortunately, there aren't any reductions that I can do. So 15 times 15 gives us 225. 225 times 15 gives us 25, 10, 12, 11, 5, 2, 2, 3375. But then I have to divide that by 4. By 4. 2 times 2 is 4. So then my last step, I need to take 3,375, dividing it by 4. It's going to go 8 times. 32 gives me 1. 17 is going to go 4 times. 16 gives me 1. 15 is going to go 3 times. Minus 12 gets me 3. So the total volume is 843 3/4 cubic feet. Seeing a lot of blank stares out here. Was it just going too fast, or is there a piece you didn't understand? Well, technically it was supposed to be correcting your work. You should have had all these answered already, which is a big part that it should be going that fast, because all you're doing is correcting stuff. Yeah? Eventually. Any questions on anything that was done here? You guys understand how we got the 250 boxes?
Yes.
You guys understand how we do this multiplication? It is big numbers. Nothing I can do on that. Okay, let's turn the page. We got one more page to do before we go over the homework. Yes, you have homework tonight. Guys, solve each problem. Don't worry about the fractional cubes piece. You don't have to make fractional cubes. But if they tell you about the fractional cubes, you do need to figure out how many they need. So basically, don't worry about that. Just solve using the volume formula with those dimensions. On this one they gave you how many 1/6 cubes can you fit. You can do that one the same way we just did the rectangular, the truck one. And this one is another one that is just 3 to find the volume of. So you guys have, we'll give you about 8 minutes to do that.
When's Destiny coming back?
See how many we get done. We'll work through as many as we can in the time we have left. The first one should have been very easy. This is just length, width, height. So I'm putting them in the formula. 1 1/4 times 1 times 1/2. So slam dunk, we have 5/4 times 1/1 times 1/2 gives us 5/8 cubic feet. There's our answers. Number 2, she makes earrings, packs them into boxes that measure 6 foot wide. How many 6 foot cubic boxes can she fit into a shipping box? That's 1 1/6 by 1/3 by 1/3. So this is another one of those. I'm just taking those 3 different dimensions, dividing them each by 1/6 to figure out how many I can do in each. So 1 1/6 divided by 1/6, slam dunk, gives us 7/6 divided by, or times 6/1. Those are going to go away, gives us 7 boxes. We've got 1/3 divided by 1/6, or 1/3 times 6/1 is going to give us 2. And the third one is the same. It's 1/3 by 1/3. Again, a picture might help you on this, because I've got a bottom of 7, 2, and then 2 up. It's a little harder to draw the 2-dimensional figures that quickly, but what we're saying, I have 7 boxes this way, 2 boxes this way, 2 boxes this way. So I have a base layer of 14 times 2 is going to give me 7 times 2 times 2, 28 boxes. Will fit. Which is another one. Some of you didn't put full sentences on your 2-word problems. Lots of points on that one too. Our last one. She wants to put carpet. How much carpeting will she need? So this one is going to be interesting. So she wants to put carpet in the closet. How much carpeting will she need? Really, that's just a area question. So I need to get the base of it. So it's 4.5 times 2 2/3. Because my area, they said it's a rectangular, so it's going to be base times height, or length times width. Excuse me. Slam dunk both of these. Gives us 9/2 times 6 7 8/3. A couple reductions I can do makes it nice and easy. So that one is just 12. So she needs 12 square feet of carpeting. And our last one, he wants to store cube boxes that are 1/2 foot wide. How many boxes will fit in the storage closet home? So that's another one. We're going again on each of the pieces. So 4 1/2 divided into 1/2 feet. We still need to slam dunk. 9/2 times 2/1 allows us to get 9 boxes in that direction. 2 2/3 divided into 1/2 gives us 6 7 8/3 times 2/1, or 16/3, or 5 1/3. So really I can only do 5 boxes in that direction. And then our last one is 6. 6 divided into halves. 6/1 times 2/1 gives us 12. So we're looking at 9 times 5 times 12. 12 times 5 is 60. So that gives us 9 times 60, or 540 boxes will fit. There is some leftover room in that closet, so the 1/2 foot wide boxes didn't work the greatest because of that 2 2/3 foot deep depth. Questions on any of that? Maverick? Unfortunately, you chose to use the restroom again, so you missed that whole piece. You and I will have to talk about it later. Right now, we're talking about tests on the homework stuff. Okay, let's go to page 97. Here's your first page of homework. If you haven't torn it out yet, please do so, unless you decide that you want to go take the whole book home. Journal entry. Describe how you can determine the dimensions of cubes that will fit in a rectangular prism completely with no overlaps or gaps. In other words, this was the whole piece we gave you, 2 steps. I'll give you hints. Step 1 was find the LCM. Okay, if I'm using fractional units. All the rest, determine the number of 1/2 inch cubes that can pack the prism. So basically figure out how many will go into each of the 3 dimensions. And then you're going to multiply those 3 numbers together. Number 2, what's the volume? So on this one, you're going to need to find the volume of a 1/5 foot cube. In other words, 1/5 times 1/5 times 1/5. And then divide 300 by that number. Number 3, finding the volume. These are really easy. All you're doing is using your formula. Length with height. Determine length, width, height. Make sure you're labeling it on your figure. Put the numbers into the problems. Okay? Last page, 98. You have 2 more problems, just like the one you did on the previous page. You don't have to do the stretch, but if you want to, I will give you a hint. For a triangular prism, the only thing that's going to change is my volume formula. Because it's a triangle, it's going to be 1/2 of the length times the width and the height.
So it's the normal 60 divided.
Yep. Again, Mr. Mortit, I'm going to take one of the even numbers and divide it by 2. I'm not going to divide the whole thing. Save yourself math. It's not. So, should be a relatively easy homework assignment. Any questions on the homework before I stop? Okay.